Hi everyone, my name is Jadamu Kubimana, an embedded system intern at Emertxe. During this internship, I developed a microwave oven simulation project using a microcontroller called PIC16F877A. In this video, I will walk you through the design, implementation, and a live demo of the project. So, let's dive in. First of all, let's see the overview of our internship. The internship focused on embedded systems using microcontrollers. The objective was to learn hardware, software integration, interfacing peripherals, and simulating embedded designs using PICSimLab. So this presentation covers the project development cycle, tools used, and implementation details. Let's see the learning outcomes that I gained from the internship. First was introduction to C, where we learned the C programming, and we saw the conditions, groups, and operators, arrays and pointers, functions and strings, memory and storage classification, introduction to embedded system and microcontrollers, MPLAB IDE, XC8, PICSimLab. Those was the tools we used during our implementation of the microwave oven project. We also ran the introduction to various peripherals of the microcontroller called PIC 16F877A. We also saw interfacing various peripherals of PIC 16F877A, and also we have given multiple quizzes during the internship. Now let's see the goals of the internship. First goal was to gain hands-on experience with microcontrollers and embedded system development. Second was to understand and apply real-time processing using timers and interrupts. The third one was to simulate and verify embedded designs before implementation, and also to work with various interfacing components such as LCD, keypad, and tactile switch. Let's see the content that we have seen during our internship. First of all, the first was introduction of microwave oven. We also we saw the project requirements. Some of them were microcontroller, PICSimLab, LCD, matrix keypad or MKP, interrupt service routine, ICL, timer, and also the final was project implementation. And I think we will see the demo after this presentation. So the project, as I was saying, it was microwave oven. Let's first see the introduction of the microwave oven. Microwave oven is used to heat food using microwaves, which form electromagnetic waves. There are several modes in various microwave ovens. We are going to implement our 4 modes, and those modes are micro mode, grill mode, convection mode, and start mode, as you can see in this picture right here. So let's see first see the block diagram of microwave oven, how the microwave is designed. I think you can see here we have the central unit, which is the control unit or microcontroller, and here we have power supply. We also have user interface, which are keypad and display. We also have door and safety interlocks. And here you can see we in our microcontroller in our microwave oven, we have cooking chamber, we have also magnetron, and different other things like cooling system, which are fan and ventilation, temperature and humidity sensors, timer and clock, buzzer or alarm, and mode selector circuit. And I think some of them we will see them in during our project demo. So as I was saying, here there are project requirements, and those requirements are MPLAB IDE, an integrated development environment for microcontroller programming, and XC8 compiler. This is a compiler for C programming in microcontrollers, and PICSimLab, a simulator for PIC based microcontroller projects. We also have the microcontroller code PIC16F877A, and this is the microcontroller we used during the project implementation. And we have also 16 times 4 CLCD, which is a character LCD for data display, matrix keypad MKP for user input, tactile switch for triggering an event, and timer to manage precise time-based operations. And these are some of the images of those tools. You can see that this is XC compiler, and this is MPLAB IDE, and this one below is the PICSimLab. So first of all, let's see. Let us see what is the embedded systems. Embedded system is a combination of any hardware and software that is intended to do a specific task. The embedded system in a microwave oven works as a command device. A general purpose system, GPS, is used to perform a large number of tasks, whereas an embedded system, ES, is used to perform a specific task. Here there are some types of embedded systems, which are standalone system, real-time system, networked system, and mobile system. And you can tell that this is the picture that is showing the embedded systems, where there are different devices and different things like television, have mobile phones, and some other devices. Here let's see the our project design. The system was designed using a microcontroller. As I was saying before, our microcontroller was called PIC16F877A, and that microcontroller used to interface with is a CRCD, a matrix keypad, and a tactile switch, while timers and interrupts handled event-driven execution. The block diagram of those tools we used are microcontroller, CLCD, keypad, tactile switch, and timers. And I said, which you can see here on those pictures here. You can see this is the tactile switch. This is our microchip or microcontroller called that name. This is a CLCD. This is a keypad, and also here below it is timers, and I say. So the development process and tools used. Here there are tools, as I was saying before. These are the tools we used. We used the MPLAB IDE for writing and debugging code, XC8 compiler for compiling C programs, PICSimLab for circuit simulation, and also below there are development steps we used to develop our project. First one was writing the firmware code in C. Second was compiling the code using XC8, simulating using PICSimLab, debugging and optimizing the code, final testing and validation. You can see here that this is the screenshot of our MPLAB and some codes there. You can see that these are headers files and below are source files, and I think you will see them later during the demo. And also let's see the implementation details. Microcontroller configuration setup. First, to set up of the registers, I/O ports and clock speed. Also LCD interfacing, sending characters and controlling the display. Matrix keypad interfacing, scanning rows and columns to detect key press. Tactile switch functionality, detecting a single press event using the bonds techniques. And also there are timers, and I said configuring timers for periodic execution. And here in this image right here, it is like a flow chart of how our microwave oven works. And see here there is a start power on message. You will see it when we are doing it during the demo. So we have here some stuffs here, and I think it will be better to see them during the demo of our project. So here let's see the how we worked with PICSimLab. PICSimLab so is a simulator for testing PIC microcontroller project before hardware implementation. It supports multiple microcontrollers, including our microcontroller we used, which was PIC16F877A. It allows peripheral interfacing, LCD keypad and timers, and it provides debugging features like breakpoints and step execution. And let's see about the timer and interrupts. Timers are used to generate delays, measure time, and trigger periodic events. Interrupt service routines, I say, handle critical events asynchronously, ensuring real-time processing. For example, here I can tell you a timer is set to trigger every 1 millisecond to refresh the LCD. That's one of the example I can give you. The IC reads keypad input without blocking main execution, and also that is the other example for interrupts. So let's continue to challenges that we faced, or I faced, and also solutions I provided to those challenges. So first one was keypad debouncing issue, where I implemented a software debounce mechanism. The second one was timing accuracy in ISL, where I optimized timer prescaler values for stability and also simulation delays. Here I adjusted the clock settings for better real-time behavior. And here let's see results in the demonstration. The embedded system successfully it displayed message and data on LCD, captured user input from the matrix keypad, responded to tactile switch presses, executed timer sensitive operations using timers and interrupts, and also it cooked and hit the meal and displayed the message to the user with buzzer sound after the meal was prepared. So you can see here and these pictures here. Here we have the time which was set to something, and also we have here the displayed message here which was saying time up, enjoy your meal, which means that here the meal was successfully cooked, and it was time for the person to enjoy his meal. So let's continue to the conclusion. let's conclude to our presentation. This internship provided hands-on experience in embedded systems, from microcontroller programming to interfacing various components. The project demonstrated the importance of real-time processing, peripheral communication, and debugging techniques using PICSimLab. Future scope. Let's see some of the future scope that um, I am planning to integrate. First was so in the future I'm planning to expand the real hardware implementation, integrating wireless communication, for example Bluetooth and Wi-Fi, implementing power optimization techniques. So without further ado, let's continue to our project demonstration. So let's open MPLAB ID here, and you can see here there we have our project. Well, here we project called the micro oven. It has headers file which are like file files, and we have source files which are like 6 files, and here there are codes. You can see here code, different code for of each file. And so let's run our project. Right click and clean and build. I think you can see that our project is built successfully, and let's see continue to our PICSimLab to show the demonstration of our project. So let's open here the PICSimLab, and here you can see the PICSimLab is open, and let's load our hex file, and here it is. Select it and open the file, and here you can see the message saying that the microwave is powering on. You can see here, and after that message we have our 4 modes, which are micro mode, grill mode, convection mode, and start mode. Let's for example first click on the micro mode, which is the first one. You can see I click the one, and we are seeing this message power echo and something. And here you can set the time. We can see here that our time is blinking. This is the second party, and this is the minus party. So let's for example set the time to 45 seconds, and you can see here clear, it is to clear what you have entered here, and also this hash sign is used to enter the time. Let's first let's clear the time. Like you can see that the seconds is set to 0. Let's set them again to 45 seconds, and click hash to enter the time. You can see that the fan is here, it is spinning, which shows that our microwave is starting to cook. You can see here you can click 4 to start, resume, 5 to pause, 6 to stop. For example, let's click 5 here to pause our time. You can see that time is paused, and also the fan stopped to spin. And also you can here click 4 again to resume. You can see the time is resumed, and also you can also stop our microwave. Let's stop, and we start again. Still, yeah, you can see that our microwave is stopped. So let's again do it so that you can see what happened after the cooking. Let's click 1. You can see power equal 900 watt, and here you can set time to, for example, let me set time to 10 seconds, and enter time, and wait it and see what will happen after the cooking, and see what will be displayed to our CLCD. You can see that the time is up, and you can hear that sound, which is buzzer. Also the message time up, enjoy your meal. So I think the first mode, which is micro mode, it is done. Let's continue to our grill mode, which is the second one. Click on grill mode. Here also you can set time to grill mode like 20 seconds, let me say 20 seconds. Okay, 20 seconds are enough. And don't let me continue to enter. You can see that in also it started. Let's wait and see what will happen. Also you can stop, you can also resume, or you can stop the, you can pause, you can resume, or you can stop our microwave. Let's see what will happen after the 30 seconds. Let's see. Here you can see also on green mode our the message is still the same, and also you can hear the buzzer sound. Let's continue to the third mode, which is the convection mode. And in convection mode, here you can see that you can set temperature of what temperature you want to heat your food. Let's, for example, say 110. Yeah, 110. I think it is enough. After you click enter, you can clear also. Let me clear first. You can see that is back to zeros. Let me again set 110. Okay, enter. After setting the temperature, you can see that it is we are on the preheating display, which shows us that the time remaining is this one. By default it starts from 60 seconds, and let's see after those 60 seconds what will happen. Let's wait and see. Okay, we are remaining with 35 seconds. Let's see what will happen after those seconds. I think you can see that our microwave is doing well and doing what it was intended to do, and this is the best experience I ever gained from the internship, and I think that this will be good for me. So now I see that the seconds are about to end. Let's see. Okay, you can see after seconds we are here to set time. Means that we're going to set time to 1 minute. I think it is enough. Let's enter. You can see also here you can start as you can pause, you can start or resume, yeah, something like that. So let's stop here. I think this you know what will happen after these seconds, and let's stop this microwave oven and go to start, which is the last mode here, which is in the fourth. You can see if you click on fourth, automatically the time starts from 30 seconds, and also you have those options which are the same as options we had before, and start, pause, stop, and here you can, if you click on for start, you can see that 30 seconds is added to the left seconds. It means that you can continue adding 30 seconds till your meal is well cooked. So let's wait those seconds to end and see what will happen. Okay, can stop. You can see that everything is stop here. You can also you can pause here. We pause our microwave. We can stop. I don't want to do that. Let's see, resume again and see. Okay, and see that we have 9 seconds. Let me add some other 30 seconds. You can see that I added more seconds. We are now have 1 minute and 26 seconds. So let's wait for those seconds to end and see what will happen. Okay. I think this will be also the end of our project demonstration. I think that you've seen whatever you needed to see, that our microwave is working well and is doing its job very well. So I can see that we are left with 52 seconds. um, let's wait those seconds to end. Okay. Okay, we are remaining with 30 seconds. Okay, you can see that our fan is spinning, and also second is delay r. Okay, now we are remaining with 5 seconds. And wow, time up. Enjoy your meal. Thank you for uh, thank you for being with me this time, and I think that's enough. And also, see you then. That was my micro oven simulation project built during my internship at Emertxe. I learned a lot about microcontrollers, real-time processing, and debugging embedded systems. If you found this useful, hit the like button, subscribe for more tech content, and drop a comment below. See you next time.